welcome you all to the problem solving session of week 8 of differential equation for engineers. Myself Guru Bachan from Department of Mathematics, IIT Jodhpur. I am working in the broad area of practical geometry and dynamical systems. In today's problem solving session, we mainly focus on the second order linear PDEs and their classification and how we can reduce to their respective canonical form. So let me start with the question number 1. Classify PDEs. First one is 8uxx minus 2uxy minus 3uyy equal to 0. So we have given this second order linear PD. So we have to classify it whether it is a hyperbolic, parabolic or elliptic. So let me just first recall the general form of second order linear PD. So general form is the general form of second order linear PD is A uxx plus B uxy plus C uyy plus some lower order terms. Since we are going to decide with this A, B, C only, so therefore we are not writing those expressions. That can be a function of ux, uy, u, x, y. Okay, so there might be some these kind of terms or these kind of functions. So on the behalf of this general, how we can decide? So we calculate b square minus 4ac, and if this b square minus 4ac, if this is positive, then the given PD will be hyperbolic. If this is equal to 0, then this given PD will be parabolic, and when it is less than 0, then this will be called as elliptic. Okay, so here what is A, B, C? We have to identify it first. So A is 8, B is minus 2, and C is minus 3. So what will be B square minus 4AC from here? This will be minus 2 square minus 4 into 8 into minus 3. So this will give us 4 plus 12, 8, 96, that will be 100, which is a positive quantity. So that means the given PD is hyperbolic. Okay, so in the same way, if I'll give you another example, and moreover you may observe that this is a PD. This can also be a function of x and y. Everything A, B, C, this can also be a function x and y. So this is a second order linear PD with constant coefficient, you can say. So next one is uxx plus 2 times of uxy plus 5 uyy is 0. So we need to classify this PD. Again, what we will do, we will see here A is nothing but 1, B is 2, and C is 5. Now you have to calculate B square minus 4AC, and then you have to decide its sign. and then you can classify it as hyperbolic, parabolic, or elliptic. Try this one. So here, since we are aware about value of a, b, and c, so this will be 2 square minus 4 into 1 into 5. So this will give us 4 minus 20, that is minus 16, which will be negative. So that means the given PD is elliptic. Next is the third, 4 uxx minus 12 uxy plus 9 uyy is 0. So here the value of a is 4, value of b is minus 12, value of c is 9. So b square minus 4ac will be minus 12 whole square into 4 into 4 into 9. So this is 144, and this will be again 144, which will be equal to 0. So that means the given PD in this case, or in this part, is parabolic. Okay, so in this particular question we have deal all the three types of PDs with constant coefficients of each category. In the next question we try to deal with you can say variable coefficient PD, second order linear PDs, and how their classification depend on their domain of variable ABC. So second question is classify the PDs graphically in the plane. So first one is uxx plus x minus 1 uxy plus uyy minus 2x square ux plus 3xy uy plus 2u equal to sin x. So this is our given PD. Here you can observe that the coefficients are not constant, there is a variable. So in this case what we have to do, we have to first of all calculate that b square minus 4ac. So here a is 1, b is x minus 1, c is again 1. So what will be b square minus 4ac? This will be x minus 1 whole square 4 into 1 into 1, which will give you x square plus 1 minus 2x minus 4. So this will be x square minus 2x minus 3. So on the behalf of this x, where this expression is positive or where this expression is negative, we can judge what is the classification under which this PD is going to fall. So this expression has a factorization of the following. If you will observe that here are two roots, 3 and -1, and addition of them is 2 and multiplication of them is -3. So we have to judge when it is positive and when it is negative. So for that you may do the sign convention, -1, 3. So when it is greater than 3, this will going to be positive. In between them it is negative, and before them it is positive. And exactly at this point this will going to be 0. So we draw this one in a geometric manner. How? So this is x-axis, this is y-axis. X equal to -1, that is this line, and x equal to 3, this one. So let us denote these regions with some particular way. So for hyperbolic I am using this one. So this one will be hyperbolic. So this one is your hyperbolic. This one and this one, hyperbolic. And for elliptic, in between -1 to 3. So this region is mainly elliptic. Okay. Now what is left with? Parabolic. So parabolic will exactly occur at x equal to -1 and x equal to 3. So for that I'll do exactly on these lines. So what we can do here, next one is, okay, sorry. So let me just draw it this with this one. So this is your x equal to -1. This is your x equal to -1. And next one is x equal to 3. So this will be your x equal to 3. This is your x equal to 3. So this one is your graphical representation of this region. So what I have done, that I should do in the starting also. So what we are doing, we are denoting this hyperbolic, particularly hyperbolic, with this manner. Next one is parabolic. So parabolic I am doing this one, and for elliptic this will be this one. Okay. So we are going to do the same in each and every question. So in the second part of this question, let me give you another variable coefficients of the second order linear PD. So this is uxx plus 2 times of x uxy plus 1 minus y square uyy equal to 0. So you can easily observe here the value of a is 1, b is 2x, c is 1 minus y square. So again you have to calculate here b square minus 4 times of a into c. This will be 2x square plus this will be, sorry, minus 4 into 1 into 1 minus y square. So this will give you 4x square minus 4 plus 4y square. So if you will observe that this will be x square plus y square minus 1. So from here, let's try ourselves how we can classify them. Then I will let you know. So have you got something? You can easily observe that this is a circle centered at 0, 0 and of radius 1. When this value is 0 on the boundary of the circle, that will be going to be a classification under parabolic category. So this is your x, this is y, and since this category fall under boundary fall under parabolic category, so we will draw this with this version. So this one is a circle which is center at origin and radius is 1. What if we talk about inside the circle and outside the circle? So outside the circle you can take any point. For example, you have taken this 2 comma 0. So clearly you can see that at 2 comma 0 this value will be positive. So that means this outer region will corresponds to hyperbolic classification. Okay, and the inner version will then corresponds to elliptic. This will be elliptic. Okay, and let me also write this one as boundary as parabolic classification. So in the same way, let me give you one more geometrical representation. 1 plus y square u xx plus 1 plus x square u yy is 0. So it is easy to see that now that a is 1 plus y square and b is 0 and c is 1 plus x square. If you will calculate b square minus 4 times of a into c, this will give you 0 square minus 4 times of 1 plus x square into 1 plus y square, which will give you 4 times of 1 plus x square into 1 plus y square. Clearly this value is negative for all xy from R square, or you can say for all xy in R. So that means over whole R square this PD is going to be anyway elliptic. So we draw it. this is your x, this is your y. Since it is elliptic on whole r square, so we will shade like this. Whatever it happen, this can not even be 0 elliptic, because you can observe here this is greater than equal to 1 value, and this is also greater than equal to 1 value. So this is never is going to be even 0. So on whole r square, this PD is nothing but elliptic. Till now we have talked about the classification of second order linear PD with constant coefficient and with variable coefficient. Now the rest part is how we can solve them. So the method to solve them is to change into the canonical form. So let us first how to change into the canonical form and how it will help. So it will reduce the equation in a somewhat simpler form, somewhat classified form, so that we can even solve them by manually or in special category. We can they might fall in some special category so that we can deal with them. So let me first of all give you some examples how to get the canonical form of a given second order linear PD. So for this, here's a question number 3. Reduce the PD, and obviously this PD means partial differential equation. So I didn't mention that because it is quite obvious. So reduce the PD to uxx minus 2uxy plus 5uyy equal to 0 into uh, into a normal, or you can say canonical form. So we have given this PD, and we have to reduce into normal or canonical form. So the approach will going to be somewhat similar. First of all, what we will do, we will calculate b square minus 4ac, because this can only decide how we can transform the variable x and y in which xi type of xi and eta. So there will be 3 category of xi and eta again, and that is going to depend on this sign of this b square minus 4ac. So how? So here what will be b square minus 4ac, since b is minus 2. I'm writing somewhat direct because we are aware how to calculate it now. 4 into 2 into 5. So this will be 4 minus, this will be 40. So this will give you minus 36, which is less than 0. That means the given PD is elliptic. So since it is elliptic, so after that what we have to do, we have to now we have to classify them. Classify, we have to write its characteristic equation. So what is the characteristic equation? So characteristic equation is like this: dy by dx is equal to b square minus 4ac divided by 2a. So from with this we can get the characteristic equation. So how? So this will be minus 2 plus minus under root minus 36 divided by 4. So this will give us minus 2 plus minus 6 iota divided by 4. So this will give us minus 1 by 2 plus minus 3 by 2 iota. So from this you can see that dy by dx once equal to dy by dx, once it will be equal to minus 1 by 2 plus 3 by 2 iota, and if you will integrate this one, so this will be dy integration of minus 1 plus 3 iota divided by 2 dx. So this will give us y equal to minus 1 plus 3 iota divided by 2 into x plus c1. In the same so from here you can moreover simplify like this, plus 1 minus 3 iota divided by 2 into x equal to some c1. In the same scenario, if you will deal with this dy by dx equal to minus half minus 3 by 2 iota, so this will give integration of minus 1 minus 3 iota divided by 2 dx. So this will give us y equal to minus 1 minus 3 iota by 2 to x plus c2. This will give us y equal to plus sign 1 plus 3 iota divided by 2 into x equal to c2. So from this we can judge what can be our transformation. So we can use the transformation xi as, I am choosing in such a way, so this will be positive. So I am taking xi as 1 y plus 1 plus 3 iota divided by 2, and eta as y plus 1 minus 3 iota by 2 into x. Now the point arises that here is the real and imaginary part. So if you have followed up the lecture, you might get to know that in this kind of scenario, what we will use, we will take the real part and imaginary part in a different manner, deal with that, and then we'll try to convert the equation into the canonical form. So how it will going to be happen here? So what you will do, you will take alpha as xi plus eta divided by 2, and while beta as xi minus eta divided by 2 iota. So what it will give again? So when you will add them, then obviously they are conjugate to each other, then its imaginary part will going to be cancel out. So you will left with 2y plus again x by 2 plus x by 2. It will give you x divided by 2. Okay. Next, beta will be xi minus eta. When you will subtract them, you will left with the imaginary part, 2 times of imaginary part. So this will be 3x iota divided by 2 iota. So again this will give you y plus x by 2, and beta will give you 3x by 2. So from here you know what is your alpha and what is your beta, that is the transformation. We will transform this xy into this alpha beta to get to the canonical form. So how will you get? You will, since we know that we change the independent variable ux, so we want to replace this uxx, uyy and uxy. So for that you need to first calculate ux in terms of uxy. So by chain rule, you know that ux means partial derivative of u with respect to x. So what you can do, partial derivative of this with respect to alpha and alpha with respect to x. In the same way with respect to beta and beta with respect to x. So this will give you partial derivative of u with respect to alpha, you will write it as u alpha, and del alpha by del x, it will give you half. Next, u beta, and this will give you 3 by 2. In the same way, what you will do, uy, you will calculate uy. So del u by del y, this will give you del u by del alpha y plus partial derivative with respect to this beta and partial derivative of beta with respect to y. So this will give you u alpha, and with respect to it will give you 1 plus u beta, and this beta with respect to y, here there is a no component of y, so this will directly give you u alpha. So from here we have to follow to the uxx, uyy and uxy, since only these terms are in our given PD. So what we will do, we'll calculate uxx. So again, so partial derivative of u with respect to x of u alpha plus 3 times of u beta divided by 2. This is all we have given. What we will do, del by del alpha of this quantity, u alpha plus 3 u beta divided by 2, and next will be what? Next will be del alpha by del x plus del by del beta of this same quantity, 3 u beta divided by 2 of del alpha del beta by del y. Oh, I'm sorry, x, since we are again differentiating with respect to x. So this will give us, when we differentiate with respect to alpha, so u alpha alpha plus 3 times of u beta alpha, and this is 2, and this will again contribute as half, plus when you will differentiate with respect to this, u alpha beta plus 3 times of u beta beta divided by 2, and this will contribute as 3 by 2. Since we are working in the we have know that u has a continuous partial derivative with respect to x, y, alpha, beta. So that means u alpha beta is nothing but u beta alpha. So u alpha beta is nothing but u beta alpha. We are aware about this, so we can easily add them. So this will be u alpha alpha. From here 3 times of u alpha beta, and from here again 3 times of u alpha beta. It will be 6 times of u alpha beta, and from here 9 times of u beta beta divided by 4. So you got the value of uxx. Next is you have to calculate uxy. Okay, so the easiest way, so what you have to do, del over del y of this del u by del x. What is the value of del u by del x? This is del by del y of u alpha plus 3 times of u beta divided by 2. So this will give you, again, first with respect to alpha. So when you will differentiate with respect to alpha, you will get u alpha alpha plus 3 times of u beta alpha divided by 2. And when you will differentiate alpha with respect to y, since we are differentiating with respect to the second variable, so this will give you 1, because alpha has only y in it. So del alpha by del y will be nothing but exactly 1. What about the next one? When you will differentiate with respect to beta, this will give you u alpha beta plus 3 times of u beta beta divided by 2, and this will contribute as 0 since beta has no terms of y. So from here you will get u alpha alpha plus 3 times of u beta alpha divided by 2. Now you have to only calculate uyy, that is del by del y of del u by del y. And what is the value of del u by del y in terms of alpha beta? It is nothing but exactly u alpha, since beta has no terms of y. So this will again will give you u alpha alpha and del alpha by del y, that is 1, and del beta by del y is 0, so we don't need to write the second term. So now you are aware about all the values of uxx, uyy and uxy in terms of independent variable, or you can say transformation alpha and beta. So we will put these values in the given differential equation and try to reduce to the canonical form, or you can say normal form. So what is the given equation? So given equation is, this is uxx, sorry, yeah, 2 times of uxx minus 2 times of uxy plus 5 times of uyy. So 2 times of uxx means 2 times of uxx. So what is the value of uxx? So let me just first write the original equation, then we will substitute the value of these uxx and uyy. This will be 2 times of uxx, this is a given equation, 2 times of uxy plus 5 times of uyy equal to 0. So what we have to do, 2 times of this uxx, and this is the value of uxx. So we will substitute this one here. So let us substitute here. So this is the value of your uxx. Next one is uxy. So for uxy, what we will do, so we will see here, this is the value of uxy. So we will substitute this value here. Next is uyy. This is nothing but simply u alpha alpha equal to 0. So in the simple manner, you will take the LCM as 2. So from here you will get u alpha alpha u alpha alpha plus 6 times of u alpha beta plus 9 times of u beta beta. Here, since we are taking the LCM as 2, so this will be 2 times of u alpha alpha minus 6 times of u alpha beta. Since we are working with the u is a continuous function with respect to xy alpha beta, so u alpha beta is nothing but u beta alpha. From here, 10 times of u alpha alpha will be equal to 0. Now try to see these terms u alpha alpha and combine them. This is u alpha alpha, this is u alpha alpha, this is. So we have 3 terms of u alpha alpha, which will give us 9 times of u alpha alpha. Next is, this is u alpha beta, u alpha beta. This will cancel out. We are left with 9 times of u beta beta will be equal to 0. So you will get u alpha alpha, u beta beta is equal to 0. This is your asked canonical form. This is a normal form, or you can say canonical form of the given PDE. And you can also observe that this is, since this was a elliptic PDE, the classification was elliptic, falls under elliptic PDE. So this is nothing but look like Laplace equations. Okay. So here we have done this classification of PDE in this question, and we will reduce it into its canonical form, or you can say normal form. But since here we are dealing only with constant coefficient, so let me give you one more example with this constant coefficient, or you can say before that let me mention here some key point, that is what is exactly here the name I have took the characteristic equation or something. So from here what you can say, let me just mention here from the class notes. So your characteristic equation and characteristics curves are, so these are your characteristic curves, you can say these are your characteristic equation. Since we are getting two equations, so I am mentioning as characteristic equations rather than characteristic singular. I am saying at plural. In the same way, the solution will be treated as characteristic curves. So how you can treat them as characteristic curves? So even this one is also characteristic curve, and again we have transformed, so this can also be treated as characteristic curve. Characteristic curves. Since we are transforming into the plane xy to the alpha beta plane. Now in the same way, if I'll give one more example to reduce into the canonical form. Question number 4. Reduce the PD, and PD is given as uxx minus 2 times of uxy equal to 0 into a normal form, or you can say canonical. So this is the similar to the above question. So first you may try at your own, then we can discuss it here. So let us first classify this PD. So here the value of B is 0, can clearly see that. and a is 1 and c is minus 2. So 0 whole square is 4 into 1 into minus 2, which is 8, that is greater than 0. That means the given PD is hyperbolic. So since it is hyperbolic, then again what we have to do, we have to uh, find its characteristic curves with the help of characteristic equations. So characteristic equation will be dy by dx, d value of b 0 under root b square minus 4. So let me see here, I have mentioned the formula or not. So we have mentioned a formula, so I am using this formula. So b square, that is 0, b square minus 4ac we have calculated, that is exactly 8. Okay, so will it be, let me just cross verify it whether it was 8 or something else. We are dealing with question number 4. So I think there is some typo in the equation. So it is no, we have made a small error. So here the value of b is minus 2 and a is a 1 and c is 0. So minus 2 square minus 4 into 1 into 0, which will give us 4. Although it will not affect the PD, the classification of PD, it will again fall under this hyperbolic category. So it will be minus 2, 4 divided by 2. So when it will be minus 2, minus 2 plus minus 2 divided by, once it will give 0 and other time it will give us minus 2. So here I forgot to mention one thing in the earlier question also. We have we are choosing this transformation in such a way uh, that our Jacobian is 0. So from here, if you will calculate the Jacobian, so this should be 0, so that while solving you can transform, or you can get the inverse into the x and y. Since you are transform this system into the alpha beta, then you have to get to the, once you solve the equation, you have to substitute the value of alpha in terms of x and y. So it will only happen when this Jacobian is 0. And how we calculate this Jacobian, I'm denoting it as alpha beta xy. There are many different notation. So this will nothing, this is nothing but del alpha by del x, del alpha by del y. So for simplicity I'm denoting in this such a way. So del beta by del x, del beta by del y. So this will be 1 by 2, 3 by 2, 1, sorry, so 1 by 2 with respect to y will be 1, and this will be 3 by 2, and this will be 0, since there is no term of y in beta. This will be minus 3 by 2, which is a non-zero. So that means we can again retransform, or we can get the inverse transform of alpha beta in terms of x and y. So we need to always we prefer to check these things. Okay, so next is in this, so let us come to this particular question. So in this scenario you will get dy by dx once 0, and dy by dx once it is minus 2. So from here y will be nothing but directly constant. From here if you will integrate, this will be minus 2x plus some c2, and from you can write y plus 2x equal to c2. Now you can take your xi and eta in simply directly here. Since there is no imaginary term, we can directly take as xi and eta, and we can try to transform our system. So what we will do, we'll take xi as y, eta as y plus 2x, and first of all we will check its Jacobian xi and eta with respect to x and y. So differentiation of xi with respect to x will be 0 since there is no term of x. It will be 1 since there is y only. So this will be 2, this will be 1. So this will give you minus 2, which is non-zero. So we can get the inverse transform. So now we can convert our system into the canonical form. How? So again we have to calculate that uxy and uxx. So first of all ux will be u alpha del alpha by, oh sorry, since we are dealing with xi and eta, so let me use the notation u xi dou xi by dou x, u eta dou eta by dou x. So this will give you, since there is no terms of x in xi, so this factor will be nothing but 0, and from here this will be 2 times of u eta. From here you can also calculate uxx. So uxx will give you, again you have to differentiate with respect to x of this u eta with respect to x. So this will be u eta xi del xi by del x is 0 plus u eta eta, and this will contribute as 2. So ultimately you will get 4 times of u eta eta as the value of uxx. Now we have to calculate uxy, and there is no term of uy, so we don't need to calculate that. So uxy, we know the ux value of ux. Now we have to differentiate with respect to y. So 2 times of, first of all, u eta xi, and xi with respect to y will give you 1 since xi equal to y, plus next will be u eta eta, and this will again give you 1. So from here you will get the value of u xi 2 times of u eta eta. So for your sake of simplicity, I may write here as the value of xi x is 0, xi y is 1, eta x is 2, eta y is 1. In the same way, the above, before calculating its Jacobian, I may write as alpha x is 1 by 2, alpha y is 1, beta x is 3 by 2, and beta y is 0. Okay, so here you got the value of uxx and uxy, or your given original equation is uxx minus 2uxy is 0. So uxx minus 2uxy is 0. So this will give us 4 times of u eta eta minus 2 times of this u eta xi plus 2u eta eta 0. So let me just write it in this way. So this will give us 4 times of u eta eta minus 4 times of u eta xi minus 4 times of u eta eta will be equal to 0, and this will directly give us u eta xi or u xi eta. You can write anything because u is a continuous function, or u has a partial order derivative, second order partial order derivative. So this is your a normal form of the given PD. Okay, so now till now we have done. We have learned the examples of classification of second order linear PD with the constant coefficient first of all, with the variable coefficient, and we draw their classification in a geometrical manner. Now we have we have done two illustrations that are based on constant coefficient second order linear PD, and we have transformed it into a canonical form. Now the rest part will be what will be the case when we are going to deal with variable coefficient and how we can transform into the canonical form, you can say normal form. So for that, let me write the Next question. So in this we have reduce the PDE, and given PDE is uxx plus 2x plus 3 times of uxy plus 6 times of ux uyy is equal to 0 into a normal form, or let me write it here for this time, canonical form. So here we have given with the variable coefficient, and we need to first of all classify its category, whether it is parabolic, hyperbolic or elliptic. This will refer us to how to choose the characteristic curves, and we have to then check its Jacobian with respect to the initial independent variable, and if it is non-zero, then we will start the transformation process and we will calculate uxx, uxy and uyy and put in this equation to get to the canonical form. So try this one and we will discuss. So let us start first of all with its classification. So clearly the value of a is 1 and b is 2x plus 3 and c is 6. So b square minus 4ac will be 2x plus 3 whole square minus 4 times of 1 into 6, that is 24. So this will become 2x minus 3 whole square. Okay. Now there will be two classification. One is when x equal to 3 by 2, this will be 0, and this will be 0. If x equal to 3 by 2 and if x greater than, or if x directly not equal to 3 by 2, then this will be strictly positive. So there will be two category, hyperbolic and parabolic. But in most of the scenario, since this is hyperbolic, so we mainly focus on that. Although we can, for a practice perspective, we can calculate also parabolic with respect to this parabolic also. So I'll do two case, but we majorly focus on this hyperbolic part. So for this hyperbolic, the case when x is not 3 by 2. So in this case, the given PD is hyperbolic. Okay, so we will try to get, with respect to this hyperbole, the characteristic equation. Dy by dx will be 2x plus 3 plus minus under root of the value of this b square minus 4ac, that is 2x minus 3 whole square, divided by 2, which will give us 2x plus 3 with 2x minus 3 divided by 2. So this will give us, when we will add these, so 2x plus 2x will be 4x, and at the end we'll get 2x, and when we'll subtract them, then 3 and 3 will be 6, contribute as 6, and then 3. So there will be two, since two characteristic equations, so we'll get two characteristic curve here simply. So dy by dx will be 2x and dy by dx will be here 3. So if you will solve this, you will get here y minus x square equal to some c1, and from here y minus 3x is equal to some c2. Okay, so what will be a transformation we should use? Xi as y minus x square and eta as y minus 3x. So here simply xi x will be minus 2x, xi y will be 1, eta x will be minus 3, and eta y will be 1. So what will be its Jacobian? Xi, eta x and y is minus 2x, 1, minus 3, 1, which will give us minus 2x plus 3. And we know that x is not equal to 3 by 2. That means this will not be equal to 0. Okay. So since this is not equal to 0, that means we can proceed with this transformation, and we'll try to calculate the value of ux first. So this will be u xi, and the value of xi x, that is minus 2x, plus u eta, and the value of eta x, that is minus 3. So this will be minus 2x u xi minus 3 eta. Okay. Now here we proceed as uxx when you will differentiate with respect to x. So first will be minus 2 times of u xi, then minus 2x u xi and xi x, that is minus 2x. Minus 2x u xi eta, and u eta x is minus 3. Next one is minus 3 times of u eta xi, and xi x is minus 2x. Next is minus 3 times of u eta eta, and eta x is minus 3. So we need to just solve it a little. So minus 2u xi plus 4x square u xi xi. Since u is has a continuous second order partial derivative, so u xi eta is again u eta xi. So this will be plus 6x, and here is also 6x, so this will be 12x u xi eta plus 9 u eta eta. So this will be your uxx. Next is uxy. So for uxy, we have to differentiate this ux with respect to y. So this x will not disturb us. U xi xi, and xi with respect to y, the value is 1. So this will be as it is, minus 2 ux u xi eta. Eta with respect to y is 1. So this will be as it is. Next is minus 3 u eta xi, and xi with respect to y is again 1. Next is minus 3 u eta eta, and u eta eta with respect to y is again 1. So this will give us minus 2ux xi xi minus 2x plus 3 u xi eta minus 3 times of u eta eta. So from here you get the value of u xy. So uy will be u xi, and xi with respect to y, that is 1, and u eta and eta with respect to y, that is also 1. So uyy will be simply u xi xi with respect to y, u xi eta and u eta xi will be 2 times of u xi eta plus u eta eta. Okay, we got these values of uxx, uyy, and uxy, and our original equation was in terms of these uxx and uyy. So let me write first of all original equation: 2x plus 3 uxy plus 6 times of x uxy equal to 0. So what I will do, I'll first of all write uxx, and in terms of, in this u xi xi term, u xi eta and u eta eta, so that it will be easy to simplify it. So this is our value of uxx. This is the value of uxx. Okay, next, since uxx has no multiplier, so we will not have to worry about it. Next is 2x plus 3 times of uxy. So first of all, let me write here 2x plus 3 times of uxy. So what is this uxy? So this is your, next is 6x times of u xi eta. 6x times of this uyy, sorry, this is this value. So this is nothing but equal to 0. Now we have to solve it in some smarter way to decrease the calculations in somewhat sense. So this is 2 times of u xi xi plus 4x square u xi xi. So this will be plus 12x u xi eta plus 9 times of u eta eta. Okay, first of all, the terms of u xi xi will give us with the negative sign 4x square minus 6x u xi xi, with the negative sign 2x plus 3 whole square u xi eta minus 6x plus 9 u eta eta, and the last term will contribute as plus 6x u xi xi plus 12x u xi eta, and the last term will be 6x u eta eta equal to 0. Now we will cancel some factors that are cancelling. If you will observe that this factor will cancel out, this will be plus, so I think this will left. Let me just recheck it. So u xi xi should be cancel out in some sense. So how? Let us see that. So the given equation is uxx plus 2x plus 3 into uyy. So let us just re-verify our values. Our first value was uxx as minus 2 times of, this is question number 4 or question number 5. Question number 5, this. So our transformation was, okay, y minus 3x, till now it is correct. Now here, okay, this is 4x square u xi xi 9u eta eta plus, till here it is correct. Then minus 2 times of x u xi eta, okay, and 2x plus 3 u xi eta minus 3 times, since here correct, here uyy 2 times of this, okay, till now it is correct. Now while solving we must left with this term, so I think we might we should take care that we should not do some sign error. So from here this will be 4x square will be going to be cancel out, and this uxx plus 2x plus 3, okay, so just we have made a sign error, so this will be plus, so these 3 terms will going to be cancel out, okay. And now let's see u eta eta, so this will be negative sign. Just let me change this one as so this 3 will cancel out. Now you will left with this u xi eta, so u xi eta, so this will be 12 12 plus 12x, that is 24x minus 2x plus 3 whole square u xi eta minus 2 xi equal to 0. Okay, so we know the value of this xi and eta as some y minus x square and y minus 3x. So we need to transform this term in some sense. So how we can transform it? We know that xi is y minus x square and eta is y minus 3x. So what will be xi minus eta? This will be y will cancel out, so this will left with 3x minus x square, okay. So and this, what is this square? 24x minus 2x plus 3 whole square, this is 24x minus 4x square minus 9 minus 12x, which will be 12x minus 4x square minus 9. So this will give us, if you will take 4 common, so 3x minus x square, that is xi minus eta minus 9. So this is the value of this expression in terms of xi and eta. So this will be 4 times of xi minus eta minus 9 u xi eta minus 2 times of u xi equal to 0. This will be xi eta, or in simply way if I try to write u xi eta minus 2 by 4 times of xi minus eta minus 9 into 2 xi equal to 0. So this is your canonical form for the first case. That is almost everywhere, because x is not equal to 3 by 2 is the normal form of the given PD. Observe here, this quantity is a non-zero. Why? This value is, if you will see here, 3x minus x square. Okay, so x is not equal to 3 by 2, so this will never be satisfied. This will never be a zero quantity. Okay, since it is a non-zero quantity, so we can divide with it. The next one is again a case of variable coefficient, and we have to classify it first and find out its canonical form. So reduce the PD, and given PD is as sine square x uxx plus sine 2x uxy cos square x uyy equal to 0 into canonical form. So again, here the value of a b is b square minus 4ac is sine square 2x 4 times of sine square x and cos square x. So this will be your value of sine 2x, and so this will give you the exact value as 0. So the given PD is parabolic. So since this is parabolic, so let us move with this case. So dy by dx will be b, that is sine 2x plus minus under root of this 0 divided by 2, that is 2 sine square x. 2a is there, so here will be sine square x. So this will give us cot x. So from here we will get our curve y as ln mod sin x plus some c1. So y minus ln mod sin x equal to c1. So since here mod sin x has to be positive, so what we will do, we will deal with only positive sin x. So we'll assume that x is from 0 to pi. So we can do in general also. So we have to treat this mod x, mod sin x that way. So for simplicity, I'm saying 0 to pi, and the solution is varied from 0 to pi. In general, you can also do. So xi will be y minus ln sin x. Now here eta we have to choose as x, and let us check its Jacobian. So xi x will be minus cot x, xi y will be 1, eta x will be 1, eta y will be 0. So Jacobian of xi eta xy minus cot x 1 1 0, that is minus 1 that is a non-zero quantity. So we can work with this xi and eta. So ux will be u xi and xi x, that is minus cot x u xi. U eta eta x, that is u eta. U x x will be, when you will differentiate this cot x, you will get cosec square x u xi minus cot x u xi xi, and again this will repeat, so this will be plus cot square x. Next will be minus cot x u xi eta, and eta x is 1. When you will differentiate u eta xi and xi x, then this will give minus cot x, so this will be minus 2 times of this, plus u eta eta, and eta x will be 1. Now uy will be u xi and xi y, that is directly u xi, and eta y is 0, so it will not contribute anything. Then uyy will be again u xi xi. So you can calculate uyx, that is uxy, from this expression. So this will be u xi eta, or you can say u xi xi, and xi with respect to x. So xi with respect to x will give us minus cot x. So this will be minus cot x u xi xi. Okay. Next is u xi eta, and eta with respect to x is 1. Okay. Eta with respect to x is 1. So till now we have calculated these values. Now we have to put these values into the original given equation, that is sine square x u xi, u x x plus sine 2x u xy plus, original equation is plus cos square x u y equal to 0. So let us put these values, and we try to put in such a way so calculation become a little easy. So this is your factor. So this will come here. Okay. Next factor will be, so this factor will be multiplied by sine square x. Okay. So this factor will going to be multiplied with sine square x. So for that, let me write like this: sine square x, and next factor is going to be multiplied with sine 2x. So this is your uxy. The last factor will be multiplied with cos square x, and this will be directly u xi xi. So we may write it directly u xi xi equal to 0. Now we have to multiply these factors and solve for it. So first will be u xi plus cos square x. One factor is from this u xi xi, one factor is from this. So this will give us with negative sign, since it is sine 2x, so this will be 2 times of cos square x plus 1 cos square is from third term, or you can say third row, u xi xi. Now let us collect the expressions of u xi eta. So this will be with negative sign cot x, and cot x is we are dividing cot x with this sine square x, so this will give this is cot x, and it is dividing with sine square x. So let me write like this. Since here is a sine 2x kind of term, so I might combine 2 cos x sin x as sine 2x, and the left expression will be divide sin x, and one sin x will be cancel out. So this will be sine 2x. So sine 2x u xi eta. So I'm writing u xi eta at outside. Okay. So next expression is minus, or let me write like this. So 2 cot x sine square x plus cot x sine 2x. Okay. Last expression is u eta eta. So plus sine square x u eta eta is equal to 0. So let us solve this one, and we'll get to, there must be only left the terms of u eta eta, and u xi eta will have to be cancelled out in some sense. So it is easy to see that these are cancelling, so this factor will be 0. Now we have to just see these two factors. If there is no any calculation error, we have to just cross verify it. So our uxx was this one plus square x, this one minus 2 cot x. Okay, till now it is correct. And uxy is xi xi u xi eta, it is correct. Then u xi xi. Okay, so our original equation was, so this will be u xi. Okay, then this will be okay, and this will be okay. So here I think here is some error. Okay, no. So sine 2x. Okay, this is sine square x is multiplied with this 2 times of minus 2 times of cot x. This is the multiplication, and the next expression is with positive sign of sine 2x with this cot x. Okay, and the last one is cos square x uyy, that is u xi xi. Okay, so here we miss one expression, I think. Okay, so here we miss one expression. So u xi xi we have considered here already. So here we should write here sine 2x directly. So sine 2x with positive sign. So since we have taken, so there will be a negative sign. So 2 cot x and sine square x will be nothing but 2 sin x cos x, if you will observe it. So these two will cancel out, and you will left with only sine square x u eta eta plus u xi equal to 0. Now you know that eta is exactly equal to x, and eta cannot be 0. The reason is, if eta will be 0, then Jacobian will be 0. So I can simply divide this with this 1 by sine square eta u xi equal to 0. So this is our normal form of this PD. So this is the normal, or you can say canonical form of the given PD. So here eta is equal to x, and eta cannot be 0. If eta is 0, then j will be 0, which which is, so that is we are avoiding. Okay, so I'm directly writing eta cannot be 0, so only then we can transform this one. Okay, so let us move to the last question. That is somewhat again we deal with the variable type of coefficients, but here we also solve the equation, solve the PD. So question number 7, reduce the PD uxx minus 2 sin x uxy. So let me write following method: uxy minus cos square x uyy minus cos x uy equal to 0 into the normal form, and then find its general solution. So try this one, then we will discuss it. So let us discuss this one. um, our A is 1, B is minus 2 sine x, and C is minus cos square x. So this will be 4 sine square x plus 4 cos square x, which is 4, that is greater than 0. So given PD is hyperbolic, so dy by dx will be minus 2 sine x plus minus under root 4 is 2 divided by 2, and this will give you minus sine x plus minus 1. So that means y will be y plus sine x plus 1 will be some constant, and y plus sine x, okay, we have to integrate it. So since we want to integrate it, let me just open this one also, so that there might not be any calculation error. So y minus cos x minus x is equal to some c1, y minus cos x plus x is equal to some c2. Okay, so your xi will be y minus cos x minus x, and eta will be y minus cos x plus x. So xi x will be, cos x will be minus sin x, that is sin x minus 1, xi y will be 1, eta x will be sin x plus 1, eta y will be 1. So its Jacobian is sin x minus 1, 1 is 1. So it is sin x plus 1, 1. So this will give us sin x minus 1 and minus sin x plus 1, that is minus 2, that is a non-zero quantity. Now we have to calculate ux, uy, and as per the equation we need to calculate also uy also. Substitute, I mean. So ux will be u xi and xi x, that is sin x minus 1 u xi plus sin x plus 1 u eta. Okay, then uxx will be sin x minus 1 whole square u xi xi, and when you will differentiate with respect to eta, so this will be some sin square x minus 1, and it will be 2 times because of the xi eta and eta xi, and the third term will be eta eta, that is sin x plus 1 whole square u eta eta. Next is uy. So uy will be u xi plus u eta. Eta y and eta both are 1. Then uy will be again u xi xi 2 times of u xi eta plus u eta eta, and uyx is nothing but uxy, which will be equal to u xi eta, or you can say u xi xi, and xi with respect to x. Then xi with respect to x is sin x minus 1, sin x minus 1 u xi xi, and when you will differentiate with respect to eta, then and eta with respect to x, this will give you sin x plus 1 u xi eta, and the other expression is sin x minus 1 u eta xi, and when you will differentiate u eta eta, this will give you 1. So this will be sin x minus 1 u xi xi when you will add them, so this will be 2 sine x u xi eta plus u eta eta. Okay, now we have to substitute these values into the our original equation. So let me rewrite my original equation. My original equation is uxx minus 2 times of sin x xy. Okay, as I differentiate, so here we have done one error. There is a term of sin x, and this also we have to differentiate. So if you will differentiate, this will give you cos x u xi plus cos x u eta. That's all. So this is minus 2 sin x u xy minus cos square x u y minus cos x u y equal to 0. So the value of ux, we have to, no, we don't have to multiply with anything, so we may directly substitute in the following manner. So this is the value of uxx. So let me put it here. This is the value of uxx. So what we can do, we can combine these terms in this way, and this last term we may put in the end to combine with uy. Okay, now the next term is uxy. So uxy is written here, and this has to be multiplied with 2 sin x. So this will be minus 2 sin x into sin x minus 1 u xi xi. Okay, next is minus 2 sin square x u xi eta. Next term is minus 2 sin x u eta eta. Okay, now the last term is plus cos square x of u eta eta, and this is simply u xi xi plus 2 xi eta. So we just need to multiply cos square x. So here plus cos square x. So let me just rewrite it. 1 minus sin square x u xi xi plus 1 minus sin square x 2 times of u xi eta, and the last term is again plus 1 minus sin square x of u eta eta, and the last term is minus cos x into uy, and uy was u xi plus u eta. So this will be cos x u xi minus cos x u eta. This is 0, and now you will try to cancel out. So these expression will cancel out directly. Next will be, and we want to cancel out this u xi xi. We may check this. This is sin square x, this is minus 2 sin square x, and from here you will get one more sin square x with negative sign. So can we do anything with that? So let me just write it. So this will be 1 plus sin square x minus 2 sin x minus 2 sin square x plus 2 sin x. Okay, and the last expression is 1 minus sin square x u xi xi. So this 2 sin x will simply cancel out. This sin square x minus 2 sin square x minus sin square x. So we will left with the, you can say, if you will write it as cos square x, so is there any benefit? So minus sin square x, so this should be some with negative sign, I think. So okay, This was with negative sign. So what I have to do, I have to put it here. This was negative sign, minus. So this is minus, minus, minus. So since if we write minus directly, so these term directly cancel out. We no need to rewrite it. So this term and this term will cancel out. Okay. Now if you will see the last term, then sine square x and 2 sine x and minus 2 sine x will cancel out. This is 1, here will be minus 1 will cancel out, and here it is sine square x, here it is 1 minus sine square x. So we have to think about it, what we can do here. So this is minus 2 sine x. From here you will get minus 2 sine x, 2 sine square x. Okay, so let us do it here. So this was sin x plus 1 whole square and minus 2 sin x. So this will give you 1 plus sin square x plus, you can say 2 sin x. So 2 sin x, 2 and x sin x will cancel out, and since here it is sin square x and here it is cos square x with negative sign factor. So what you can do, so let me just check it. Can do it something here. So this was uxy term. So in uxy term there was expression of sin x. We have to multiply this with minus 2 sin x. So this multiply by minus 2 sin x. Okay, and then the last term, this is cos square x. Cos square x to be multiplied with this uyy with the negative sign, minus cos square x. So minus cos square x u eta eta, that is 1 minus sin square x. So let now we will left with this last one, u xi eta, and if you will solve it, this u xi eta, then u xi eta will give you, if you will solve this a little, that you might do by your own also. So this will at the end provide you u xi eta equal to 0. The reason is here it is 2 sine square x minus 2, and minus 2 sine square x, it will cancel out and we will left with minus 2. Here there will be minus 2, and again there is sine square x, and if you will solve it, you will get to the stage of, you can say u xi eta equal to 0. Okay, so when u xi eta will be equal to 0, then you can say u xi will be some function of, since with respect to eta its partial differentiation 0, then this has to be function of some xi. Now we have to differentiate, integrate with respect to xi. So this is will be phi xi d xi plus xi times psi times of eta. So this can be written as some capital phi xi psi times of eta, and this is your, first of all, is the normal form of the given PD. Okay, and this will be your phi y plus x minus cos x. So let me just write it as f. Okay, so this will be some psi y minus x minus cos x. This is the general solution of the given PD. Okay, let me stop here. Thank you.